This is very exciting. Hi, this is Dale Peterson, and welcome to the Unsolicited Response Show. Well, again, it's post S4. I think this is the second recording I've done post S4, so we're getting back into the scheme of things here. We're hoping to get an episode out every Wednesday, and I just would want to point out for the episodes, we try to answer questions, and I haven't had any questions in a while, but if you go to dale-peterson.com, you can actually record your question there, or if you want, send it into s4@digitalbond.com. And at the end of some of these episodes, we'll do some questions. If we get enough of them, we'll do a Q&A episode. But for this episode, Liz, bring up my guest here. My guest for this episode is Steve Mustard. He is currently the president of National Automation. He was the president of ISA in 2021 and involved in ISA in a variety of leadership roles before that. And he has over 30 years experience developing, managing, and securing industrial control systems. But really, the reason why I wanted to have you on the show, Steve, is that you have a new book out in the recent months called Industrial Cybersecurity, Case Studies and Best Practice, published by ISA. So as an author, welcome to the show, Steve.
Thank you, Dale. Great privilege to be here.
I'm always so impressed by anyone who writes a whole book. I mean, I've tried a couple of times. I get a chapter in and I just give up. I'm more of an article flamethrower than I am to have the discipline to get through and write a huge book. So there's books I like, there's books I don't like, but I've always got to give the author credit for going through that slog. And I would say your book, before we get into it, looked like it was a lot of work. I mean, it was heavily researched. There were a lot of footnotes. You pulled in information from a variety of sources. It wasn't just, here's my experience from 30 years written down. You wove that into the book, but you also took the time to put some authoritative sources behind it. How long did it take you to write the book?
It took about 2 years of writing, not full time, obviously, because like everybody, you've got a full-time job. But like everything, I'm really optimistic when I start a project like that and think it's going to take no time at all, and it never works out like that. But I kind of worked on it steadily over a couple of years, and then obviously there's a lot of editing and stuff that goes on after that, so it took a bit longer. But yeah, the idea was to capture my experience and knowledge, but I feel it's really important to not just present my point of view, but try and demonstrate that there's got some credibility with other sources as well. So I did capture as many other external sources as I could.
And I read it cover to cover, so I've got a lot of things I want to talk to you about, and I always find a little typo somewhere so I can always prove to the author I really read it. Like figure 4.5 was actually figure 4.4 or something like that. But
yeah, that's right.
But it was actually quite clean for a first edition. So congratulations to your editors on that. One of the questions I always ask authors is, who did you write this book for? Who is your target reader for this book?
Well, one of the reasons I wanted to write the book is because, having worked in this space for many years, I found a real diversity of knowledge and experience in this. And I know you know this as well from what you've been doing. And I wanted to try and capture as much of the information as possible so that all those different stakeholders could do it. So be it asset owners who need to understand what they need to be specifying, product vendors, system integrators, consultants, basically anybody who might be involved in the delivery or support of an industrial control system environment.
So a variety of roles, and it's published by ISA. You were president of ISA. You're obviously a big supporter of ISA, and the ISA IEC 62443 standards go throughout the book. So one of the questions, and in some cases you're explaining what they mean and pulling out highlights. I was asking myself a little bit, why should someone read the book as opposed to just reading the standards? What do you think the book brings that, would make it a better choice than starting with the standards?
Yep. Well, the answer to that, I think, is you had a blog post recently where you asked a few questions about 62443, and you made the correct observation that it's hard work for some people to get into it and know how to navigate their way through it. It's not like most standards, it's not made to be user friendly, unfortunately. It's to capture all of these requirements in a uniform way. And it's hard for an individual who isn't familiar with it to, where do I begin? What am I trying to do? And I think you made the comment about, time to time you have to go back and try and remember what it is it's trying to tell you and how you would go about securing a system. So what I wanted to do in the book was to kind of try and weave into the different sections of the book, which are kind of like a life cycle of industrial control system, to say where the standard is relevant. And there's one chapter in particular which is about the technical and design aspects, which obviously spends a lot of time in that area. But what I've tried to do is to take the salient points from the standard and try and help people say, well, this is how you would start with your system that you're trying to secure, and then how you would go through the process of securing it with all the different parts of 62443. So I don't know if I achieved that, but that was what I was trying to do.
Well, it's funny, you kind of led into one of my comments. I thought that was probably chapter 5 on system and security design, and I thought that was quite good. I thought chapter 3 and chapter 5, chapter 3 was on policy, chapter 5 on system security and design, is a good primer for anyone coming into the field as to what they should do, and almost a shorthand of some of the key points from that standard. And I'd say, much like in the article you referenced, I'd say it's a good representation of the conservative consensus that's reflected in the standard. I don't agree with all those things. We're not going to nitpick through all the ones where I think maybe the standard and the guidance is wrong. But I think if someone's looking to get that sort of information, it's really well captured there. So I'd point readers. I'd agree with you. Chapter 5, if you're going to read one chapter to say, how do I secure my ICS? Chapter 5 is probably a good, 30-page summary. So well done on that.
Thank you.
As you went through this, though, well, actually, let's talk about one more thing in chapter 5. You do address IIoT, the Industrial Internet of Things, in chapter 5. And I thought that was one of the better parts of the chapter, too. One that I would say strays a little bit from the conservative consensus. You kind of looking forward a little bit as opposed to saying this is what was. And you had a quote in there, the introduction of IIoT has led to misunderstandings around the Purdue hierarchy. These misunderstandings have enabled the creation of architectures that are not resilient against common failure modes, not resilient against common failure modes. I thought that was really well, a concise statement of the problem that we're seeing in IIoT that I haven't seen that before. But then in your example after that, you talk about a water treatment plant that had a logging issue and how they were sending the logs to the internet, and this could be a problem because they'd get fined if they didn't have them. To me, that seemed like kind of a simple example, but maybe a weak example, because you actually give the solution. All they need is some sort of data storage buffer locally that they can deal with. Do you have any other IIoT examples where you say they've really not thought through common failure modes?
Yeah, I think, well, first of all, I wanted to say that part was inspired by another one of your podcasts. So you had someone on who was talking about the Purdue model and is the Purdue model dead? And then they went into an explanation of how, you can't use the Purdue model with these new technologies because, you can't integrate them into the Purdue model properly. But I've spent a lot of time understanding the Purdue model and the original history of it. And, there's a misconception that the Purdue model is some kind of physical or architectural thing, whereas actually it's a logical design thing to help you understand all the functionality that you need in an industrial control system environment. So the answer to your question, or one of the examples in answer to your question, is with IIoT devices, commonly one example given is like vibration sensors, for instance. So say, well, we've got these new vibration sensors, and we're going to collect the data in the cloud directly, and then we're going to do some kind of condition monitoring on it, which sounds good as a use case. But then, as you know, typically those kind of vibration sensors, the probably information from that is also needed in the control room in real time, as well as this kind of slightly offline condition monitoring type requirement. And then if you haven't thought through this architecture properly, then you're talking about sending the data to the cloud and then somehow getting the data from the cloud back to the control system environment. And that's no longer in real time for a start, but also you've got the resiliency issues associated with getting the data out into and out of the cloud as well. And I think the common thing I find with a failure mode that I find most often is the one that I mentioned in the water treatment example as well, is when you have a failure of the communications, what do you expect to happen with all of the functionality that you expect, the real-time functionality? And so that's the bit that I don't think people think through. So they end up with a situation where you've got a loss of view, for instance, possibly even a loss of control, depending on what that device is doing. And then you're talking about shutting something in because you're no longer able to operate it for some reason. And then you're talking about what the service level agreement is that you need to have in order to bring the equipment back up again. And you're talking about manual operation and all kinds of other things, which could have been overcome more easily if you'd thought about the hierarchy of the infrastructure and you'd put in resilience in the right places, so that if you lost your communications, then you can still operate locally and so on. So that's the thing. People want to buy these devices. They look great, and the cost is great, and the functionality sounds great, and everything sounds great. So let's put them in, and you can communicate and collect data. And so when it's working, it's great. But no one thinks about, as far as I can see, all the failure scenarios and what you're going to do.
Yeah, I think that the interview you're talking about, we actually did on the S4 stage with Brad Hegred and Joel Langell. And that was eye-opening to me because it really distinguished that the Purdue model is not an architecture on where you put in your firewalls and your zones and conduits. It can be that. And traditionally, there was a lot of overlap when you were just talking about a site. But that's not what the model was. So I think that's really well put in the book. And the other thing that, just as you were explaining that really stuck out to me is engineers, and you're a professional engineer, engineers have dealt with this for years, right? You've said, what happens if layer 2 isn't available? What happens if layer 1 isn't available? Can the system run in a state that is not going to cause an unacceptable consequence, whether it be safety, equipment damage, outage, whatever it would be? And we just can't skip those steps with IIoT. And I think your book really, it's not a lot. It's maybe 3 or 4 pages in chapter 5, but I thought they were one of the gems in the book.
Right. Thank you. Also wanted to point out as well, from a security perspective, again, if you understand the standard correctly, you know that it's not about Purdue model communications. It's about zones and conduits, and those zones are not dependent on layers in the Purdue model. But again, even in that case, when you're talking about what is in a zone and where are the conduits between that zone and another zone, I find that people don't understand that either from a resilience point of view. Because if you're talking about securing some zone and then having a conduit, which is effectively some kind of firewall or router or something like that, you're talking about what happens if that communications channel fails. Do you know that the thing that's inside the zone can operate autonomously, effectively, without that communication? And honestly, my experience is people don't think that. They draw boxes around things and they say there's a zone, and then they say there's a conduit. And it's almost like just a graphical exercise, not an exercise in understanding the hierarchy and all the failure modes of communications.
Yeah, I think the whole concept of failure modes is something that we could do a better job of in OT security. And again, it's you point out that there's things we can learn from engineering and safety and other things, and this is probably one of them. Now, in the book, in several places in the book, you talk about certifications and leaning heavily on ISA Secure, but certifications as a concept security certifications as a concept and then as implemented with ISA Secure. But you also come across quite negative about the state of certifications, that there's so little being certified. Why do you think that is, and do you think it'll change?
Right. So first of all, I definitely want to say that I don't believe that certifications, either of people or devices or anything, is the solution. Right. I think we all agree with that. It's a part of the solution.
It's not sufficient.
Yeah.
Right, is what you're
but
saying.
It's a great starting point, because especially in the case of devices and systems, if you were compare it to the hazardous equipment analogy, which I use in the book, you're starting with something which is intrinsically safe, or in this case, intrinsically secure, and then you can make the rest of it more secure more easily. So we spend inordinate amounts of money as asset owners securing these products and systems that we buy from people. And I don't believe we should be having to do that. We should be able to buy stuff that is much more secure to start with, and then we're not spending as much time and money securing. So why do they not have these? Well, again, I think one of the things is a lot of people don't really understand the standard, and they therefore don't understand that there is this certification and what the certification is. So many times I see in specification that it says secure to Achilles or ISA secure, but it doesn't say what that means. So you don't even know what you're specifying, and you're asking vendors to do it. So I know a lot of the big automation suppliers, the Rockwells, the Honeywells, Emersons, and so on, they have got some of their devices secured, some of their systems, they've got their development lifecycle secured. So it's great start. Some of the smaller package vendors don't have any kind of certification, and there's a lot of packaged equipment out there. And then even with the vendors, if you look at the level of certification they have, because we're talking about 4 different levels of certification, from security level 1, which is the least, to 4, which is the highest, you're mostly at the level 1, some level 2, but not very many. And I would say that it's really got to come from the asset owners. They're the ones who've got to say, we want these things secure, and that's what drives the market. That's what makes the vendors do it. The only way you're going to get the vendors to do it is if they think it's got some kind of market differentiation for them. Somehow they can sell more products because they can say their equipment is secure. But if you have people who don't understand what the certifications are, they're not really going to understand that, and they're just going to end up saying, well, we'll go with a cheaper product. So it's still some way to go, but I have a lot of hope that in the next few years, especially, we're going to get better at that, and the more people are aware, all the events like yours that talk about this sort of stuff will raise more and more awareness. So we'll get there eventually. I think it's taken a long time.
But you mentioned this in the book, and you just mentioned it. You think that the asset owner demand is what's going to be required. And I sort of understand that from a standpoint. I mean, I'm a little worried about it now. You've probably seen that there's now Modbus Secure and Secure SIP, or SIP Secure. I never remember which one it is, but there's products now available for this, which, to the vendor's credit, they did, and we're not seeing a lot of uptake on that. So if I'm a vendor, I'm like, why am I bothering? And I would say the same thing with any certification, ISA Secure or anything else. If my customers aren't saying this is important to me, why am I spending money doing this? So it'll be interesting to see if that happens. Are you seeing any signs of it tipping over and that occurring?
Not yet. Seeing slightly more references to the standard in RFPs. Again, not necessarily correctly defined, but at least references. But even on greenfield projects, I mean, I've been working on a greenfield project for the last 6 years now, and like a lot of greenfield projects, you mentioned Modbus and SIP secure versions. Greenfield projects are still putting in old Modbus solutions, and they're still putting in OPC DA solutions, even though OPC UA has been available since 1992 or something like that. I can't get my head around that, but again, the stuff works, and so if you want a simple solution, you just go with what you did last time on the last project. And if the vendor and the asset owner, if neither of them are pushing forward, then you're just going to keep doing that. Now, they're being forced in some cases, like with OPCDA, to make some changes. So that's good news, I guess, in a way. But it's all a bit of a risk because we're doing it at the last minute. So I'd like to think that when we specify the next thing, people think about protocols that have been out even for 20 years would be useful rather than even the newest ones, but in the last year or two.
Well, it's funny because I stopped writing them down. I found in a sense that I don't know if you call it negative or realistic, but you seem to be less optimistic than I am about the state and the moving forward of the industry. For example, you said by and large vendors are still not providing the resources needed to pre-approve patches for release on page 5. And my experience is that most of the vendors are doing this. And the one that relates to what you just said, you said one might think that a project involving a new facility, greenfield, or an upgrade to an existing facility would present the ideal opportunity to resolve the challenge. Unfortunately, this is not the case on page 159. So, and then you talk about the frequency of technology refresh is unlikely to change in OT environments. Now, part of this could be we live in different worlds because most of the people that I'm involved with are kind of on the leading edge, bleeding edge, and they care about security, or they don't talk to me, right? I'm not an engineer. They don't come to me for engineering advice or to do a HAZOP or something like that. And maybe you're dealing with more the core, but I guess I found it a little bit depressing because I thought we were, we're not there yet. I knew that this might still be the prevalent view, but I thought it was tipping towards that. How long before you think some of those statements won't be true?
Well, so I think there's a couple of problems. One is, as you know, there's a huge inventory of brownfield sites, existing sites out there, and they're not going to change very quickly. So no matter what new innovations we come up with, we're always going to have that stuff that's out there, and that's a problem. The new projects, we know these major capital projects, they take years. I mean, I've been working on this project 6 years, but it's been going for more than that. And so a lot of the decisions were made many, many years ago before certain technologies were available. So that's an issue. But I think it is changing. The organizations, especially big asset owners, have usually quite comprehensive security teams in place now looking after industrial control systems. And so there's a good, much better awareness today than there was even 5 years ago about the issues that we're dealing with. But a lot of the things that I mentioned in the book, from my perspective, I think you're right. I come at it from an engineering perspective and a control system perspective, and then securing them. And when you look at it from that perspective, we still have a lot of people out there who are automation experts, and they're specifying things, and they've got awareness of security, but they don't have enough awareness to specify the right things. And then you've got the security people whose job it is essentially to secure what is procured. And I don't think we've quite got the capability integrated in all of these organizations so that that when you buy something that the security team has approved as well. So but I think it is, I am pessimistic about it, I have to say it, but that's because I spend all my time with these projects and I spend all my time going to facilities, and I'm just constantly disappointed that we're still struggling. Even the patching thing that you mentioned, I'm still having discussions with some fairly large vendors, and it's not obvious what qualified patch lists we've got to use for them. And I'm not saying it's as bad as it was 25 years ago, but it's still a problem that we spend more time than we should do talking about, I suppose.
Huh. Boy, that really surprises me because I've about 10 years ago, I saw, all the big players, Honeywell, Emerson, Yokogawa, Siemens, Rockwell, all have this documented process where they are, the SBOM is raising the stakes on this. They were primarily looking at patches of their own systems, patches of the operating system. maybe a couple other elements. So they weren't looking at patching of everything, but they were looking at the things that the asset owners, their customers, were looking to patch. They weren't they weren't really up for patching everything yet. I still don't think they are, but I can see where, depending on where you are on the maturity curve, you could be much more pessimistic or optimistic about that. You need to find some customers that are on kind of the leading edge that are saying, "What else can we do?" It's much more encouraging.
Right.
So I'm talking, I should mention your book again, Steve. I'm talking with Steve Mustard. He's the author of Industrial Cybersecurity, Case Studies and Best Practice, published by ISA. And I assume, is it available? It's available on the ISA site. Is it available on Amazon as well?
At the moment, it's available on Amazon in Kindle format. It will be and should be available soon in printed format for those people who still like the old physical copy.
Yeah, and it's I would say, from a standpoint, it's 200 some pages, like 220 pages or something like that. It's not a thriller. It's not an action adventure book, but it's very readable. It's not a hard read. You're not going to labor to get through it. I think you mix in the stories and the facts with the data and all that, so it's kind of an easy read from that standpoint. One other area that you touched on that I think is really important was in chapter 4, especially the first half. You talk about a lot of the things, and this would probably be of more interest from people that don't have the engineering and operations experience. You talk about a process hazards analysis, and you mentioned the security PHA book, which is quite good. I've had the authors on that book, and HazOps and all these other processes that are used in operations and engineering to address risk. I thought that was very important, but I also thought it got a little short shrift in the book. It's maybe 10, 15 pages. I guess, to ask it in a question, how important do you think that part of it is in managing risk? Because it was a small part of your book, but to me, it seemed like it's something that engineers and operations can really latch on to. I'm thinking of things like INL's CCE and other things that are consequence informed engineering and all sorts of things like that really would be a key part for an engineer or operations type learning how to manage cyber risk.
Yeah, I think that is a really important aspect of understanding industrial control system risk. I suppose it was relatively short part of my book because I didn't want to I wanted to essentially reference people to Jim and Jim's book, because I think that's a really good description of the process in detail. But I think that is one of the biggest challenges. Is, from my perspective, there's a couple of issues. One is, if you're trying to explain what the risk from a cybersecurity perspective is to process engineers or operations folk, they often don't get it when you talk about it in cybersecurity terms. But if you talk to them in hazard terms, the things they understand already anyway, it makes immediate sense to them. So really, my attempt is to try and have people understand cybersecurity is just a contributing cause to an incident. It's not a special type of risk. It's not a special thing that we have to treat separately. And in fact, if you treat it separately from the normal risks, then that's where I think it gets lost, because then you start to say, well, we're worried about process risks and equipment risks and people risks, and then over here there's a separate team who's worried about cybersecurity. Well, no, it's not really. It's all part of the same thing. The operations team and the process engineers, all of those people, they are worried about the likelihood of a cybersecurity incident causing loss of view, loss of control, some other issue that in the end creates a process incident of some kind. And if you tell them like that, they'll understand it. And that's what I liked about their book, was not only that, but they also identified this thing, which is really obvious when you realize it, which is that even your controls that you put in place to reduce either the likelihood or the consequence of a cybersecurity incident, if those things are electronic as well, in either software or hardware, then they are themselves hackable in some way. And you have to, in a industrial control system environment, have controls that are not hackable. So you have to have pressure release valves, and you have to have all kinds of other mechanical fail safes that cannot be hacked by someone, cannot be accidentally or intentionally modified. And that's a great way to think about it from a layer of protection point of view. Now you start to think, well, okay, I might have electronic access control, and I might have patching, and I might have antivirus, and I might have all kinds of other electronic things. But because they can fail, because you didn't patch something, or antivirus isn't running, or someone didn't manage the passwords properly, and all those kind of things that can go wrong with those controls, then you've got some things that cannot be modified in that way, and they will still protect you either from having the incident in the first place or the consequences of having it if it does occur.
Yeah, I saw in that chapter, it was figure 4.7. It was a really simple flow chart with like 7 or 8 boxes, and one of them was a decision box that said, "Are all safeguards hackable?" And that was just that little flow chart. So again, I guess I probably shouldn't push you hard on covering that, because then your book would have been twice as long. It would have been a 4-year effort, But I do like that you included it, because I think it's really important that people look at that rather than just looking at the likelihood side of the risk equation. I've got a whole keynote I give on that, so I was glad to see it in there. 2 other things I wanted to touch on quickly here. Chapter 8, safeguarding operational support. You write, if it ain't broke, don't fix it. And you give some examples of why that sort of mentality exists in operations and the engineering team that works with operations. What I couldn't tell in that chapter was whether you agreed with that, or you were just telling us the environment that security people are going to encounter. So is that something you agree with?
No, I don't agree with that. I think that we all know that mentality, and the security by obscurity type mentality is doomed to failure. I mean, it sounds good, but that it's not easy to manage things like that, and you end up in situations like we've got with that OPCDA situation, where one day you have no option but to change what you've got, and then you're up against it to try and do it in a short space of time. So I believe it'd be much more sensible if people had technology refresh plans in place that made sure that they kept things up to date in a controlled manner. So you're not doing it at the last minute. But it's no one today in industrial control system environments typically has those kind of plans in place. Again, there's a separation between what the security people might want to do, and then what those people who manage the operational budget put in place. So that's another area where it needs to be joined up.
Yeah, I might need to take you out to some asset owners I know, Steve, to make you feel a little better. They're actually doing some of this stuff. Yeah, I guess the way I've always approached it, and it's almost kind of along the lines of, talking to them in their own language, is, I call that cyber maintenance. And rarely do organizations have a run to fail maintenance philosophy for their physical equipment. They just wouldn't accept that because it breaks it. And there's all sorts of reasons why. I mean, there are some cases where you do have a run to fail maintenance philosophy. It is one that is used, but you don't see it too commonly in places with complex systems that can hurt people and cause major financial loss. So once they say, oh, well, no, we do regular maintenance or predictive maintenance, or we have some other maintenance philosophy. Well, why wouldn't you think you'd need to do that for your cyber assets? Doesn't mean you have to patch every patch Tuesday, but it means you have to have what is your maintenance philosophy, document it and do it. And I've seen people have success with that. Still, again, not as many as we need. Still probably at best. I mean, I think we're past the point where it's just the innovators. I think you're seeing the early adopters do this now, but it's certainly not the early majority or late majority yet.
Right.
Okay. So I got to get to the problem I had the biggest part with, or the part of your book I had the biggest problem with. And that was chapter 2, which is where what makes industrial cybersecurity different. And I must admit, as I was reading the book, I was like, how am I going to do this interview? But then I got past that, and I like chapters 3, 4, 5. A lot of the book I like, but chapter 2, it seems like I think you fell into the trap a lot of people from operations and engineering side fall into, that they don't really know how IT works. There's kind of a complaint that IT doesn't know how OT works. And they say, well, IT cares about confidentiality and personal information. I think you even say the first sentence in the chapter, IT cybersecurity is concerned with information security, personal information, and financial transactions. Well, IT security is a lot of it, maybe not desktop management, is hugely concerned about availability and integrity. They can measure the cost to the business of it being unavailable. Of a system being unavailable. Now, I think you're right. There is a difference. They don't have to deal with as much with human safety, and they don't have to deal with as much with equipment loss. But availability is a huge concern, and I think that chapter 2 perpetuates this myth that that IT doesn't really care about these things that we care about. And maybe the best example I can give is we're seeing with all this ransomware, Colonial Pipeline and other places, systems on IT being unavailable has a massive impact on the organization and on OT, right? If you don't have the scheduling, if you don't have the billing, if you don't have the shipping, look at what happens when AWS goes down or your favorite app goes down. Look at the impact on productivity and such, or even just look at the email server and the company goes down. Everything just stops. So availability is a huge concern to IT. So I guess that's just my rant. I'll shut up and listen if you have a differing point, but I worry that we continue to put this artificial divide between the two. And there is a lack of understanding from one to the other, but it seems to me that it goes both ways.
Yeah, that's a fair comment, and I think that is something that we've had that same discussion about CIA and IAC for decades now, and it is a bit old. I agree, and obviously it is supposed to be relative. So I mean, we are supposed to be talking about the relative importance of the things, and so I'm not necessarily saying that availability is not important. It's just that it's not as important as confidentiality and integrity. But I absolutely agree with you. I mean, as you say, Colonial is a perfect example. If you have a IT outage, then it can be catastrophic to the organization. But the reason why industrial control systems availability is so important is, as you said yourself, is because it can impact people in the environment, and it can have even more catastrophic impact. So if the Colonial Pipeline had been a control system related thing rather than a billing system, it could have been potentially worse. But anyway, I don't disagree with you that maybe we should stop talking so much about that and focus more on the other points, which is about understanding the risk in a different way. Because I think from the IT to the OT world, like I said earlier, the risk is different. We're not talking about the failure of computer equipment so much. We're talking about when the computer equipment fails, what happens to the process or the facility or the people. And I don't know whether people get that properly yet. So they still think about the failure of PLCs or HMIs and stuff rather than what that actually means to the process. So there are things like that I think we'd probably be better off spending time on. I agree.
Yeah, and I think one of the things that, again, if you've spent your life in operations and engineering and OT, IT is far from a monolith. There's so many different things going in IT. It's just like, oh, IT is this one thing, but there's different requirements for different parts, whether it's like the organization's finance system or its database system or its, its customer support system or all these different systems or whatever the back end for the app that's using. Let's say it's a reservation system. If that becomes unavailable, there are literally places that can tell you how much it costs them per minute or per second of downtime. And there are many cases where IT availability has a much bigger impact than OT availability, because you've probably, I don't know all the sectors you work in, but I've worked in some manufacturing plants where they say, hey, if we're down for 2 days, it's bad, it's not great, but we only run 2 shifts most of the time. So we'd run 3 shifts until we caught up. And it's not that big of a deal. So you go in there and you say, oh, you've got to run 24/7 or it's a disaster. They say, no, not really. We have outages from time to time, unplanned outages. It's not good. And then there are other control systems where, electric being the classic example. If that's down, no one has power, and that's, that becomes to be an issue on day one. So I just think we have to somehow deal with this disconnect. And I guess that's my biggest part. So if I was writing a book review, I'd say chapter 1, skip chapter 2, and then read through the rest of the book. But that's just one reviewer's opinion. But I do think for a lot of people, it's going to be a very useful book. I would say it's really good book for someone in operations that is looking to or forced to get more involved in OT security. I think it can get them up to speed quickly. It's not going to make them an expert. I don't think you claim the book will do that, but they'll be able to have discussions on OT risk management after reading this and be able to be in the room and discuss these sort of things, which is a major accomplishment. So congratulations.
Good. Thank you. Yeah, no, that is definitely, if that's what you think, that's a great achievement, because I would like that to be the case.
Now, I'll kind of give you the last word here. Is there anything else that you want to highlight about the book that we haven't talked about that you think is important?
No, I think we've pretty much covered everything. The key things are the risk side of things, the safety side of things, and really just understanding the standard and helping people to navigate their way through the standard. I think those are the things that I wanted to try and get over to people. And I hope that, by reading it, then, people can have a better perspective on how to manage security.
Okay, great. And one last question: do you have another book in you, or was this you gonna stop writing for a little while?
Well, I have a chapter coming out in IEEE's digital twin book. So
Okay.
the chapter is on digital twins in oil and gas, and
Okay.
that's coming out in April. But that's obviously completely different. Although there is a mention of cybersecurity in there. But is there another cybersecurity book? I don't think so. Might have run out of material. But I'll do a second edition and take on board your comments.